Hi, good morning. Today we're going to continue with the topic solving differential equation. So let's take a look at question number 1. We have a differential equation given to us. We have to find a particular solution to the given differential equation with the initial condition f of 0 equal to 5. So step number 1, so we need to separate the variables. So in this case, we get two variables, x and the y value. So we're going to put the x on one side and the y to the other side. So imagine you're trying to cross multiply, so you're going to get dy equal to x squared times 2y plus 1 times dx. So now you are going to make the 2y plus 1 disappear from the right side. To make it disappear, we divide it. So now we had this part cancel out, so we get dy over 2y plus 1 equal to x squared times dx. So now, step number 2, you're going to use the integral symbol and then integrate. So now we are going to rewrite it, integral 1 over 2y plus 1 dy equal to integral x squared dx. So this one is, we need to rewrite into a negative exponent. So we got 2y plus 1 to the negative 1 dy. And the right side stays the same. So now we're going to focus on the left side. So we had the denominator become the base, 2y plus 1. So it means u equal to 2y plus 1. So du equal to 2 times dy, 2y dy, and due to a 1, 0. So you found out that you need 2. So times 2 to balance, we put a half in the front. So now I'm going to rewrite it 1/2 integral. This turns into u to the negative 1. My dy times 2 is du. So now I finished changing the variable. On the right side, I still get the same thing. So let's focus on the left side first. So we remember this formula. So now we're going to use it over here. So we get 1/2 stay the same, Ln absolute value of u. And now we're going to integrate the right side. This is 2, so 2 plus 1 is 3. So x3 over 3 and plus c. So once we integrate, the integral symbol disappear, the du disappear, the dx disappear. So now no more integration. Okay, this integration part finished. So now step 3, we're trying to solve for y. Now we have a u over here, so we're going to substitute the 2y plus 1 back because the u equal to y plus 1. And then we're going to copy this over here. So we want to get rid of the half in front of the ln. Okay, so we try to multiply the 2, so this cancel out. So we got ln absolute value 2y plus 1, and this multiply each, you get 2x cubed over 3 and plus 2c. So we learned that e to the ln will cancel each other out. So now we're going to put e to the ln absolute value of 2y plus 1 equal to e to the 2x cubed over 3 plus 2c. And then we cancel out the ln. So we get 2y plus 1 still inside the absolute value. And now we get e to the 2x cubed over 3 plus 2c. So this is still the exponent. So now, because if you have e 2 times x and e to the first power, that is e to the 2x plus 1. So now we have an addition over here. We want to go backward. Okay, so now we're going to do is e to the 2x cubed over 3 times e to the 2c. Okay, when we do it in algebra 1, we go forward. Now we go backward. So now we are going to say k times e to the 2x3 over 3. We let k equal to e to the 2c. Now on the left side, we still get 2y plus 1 inside the absolute value. So we know that if your absolute value of x equal to 5, x equal to negative 5, x equal to positive 5. So that means x equal to plus minus 5. So we get 2y plus 1 equal to plus minus k e to the 2x cubed over 3. Now we minus 1 both sides. Minus 1, minus 1. So we get 2y equal to plus minus k e to the 2x cubed over 3 minus 1. Very last step, divide by 2. So we're going to have plus minus k e to the 2x cubed over 3 minus 1 over 2. Okay, we got the general solution. So after we get the general solution, we have to find the particular solution. So we know that we have the alpha 0 equal to 5. So now, because 5 is positive, so we're going to use equal to the y equal to k e 2x 3 over 3 minus 1 over 2. So we do substitution, y equal to k e to the 2 times 0 to the power over 3 minus 1 over 2. So now we solve for k. So we got 5 equal to, this become e to the 0. Now we're going to multiply. So we got 10 equal to k times e to 0 minus 1. 10 equal to k, because e to 0 is 1 minus 1. So k equal to 11. So my particular solution is y equal, k is 11 right now, 11 e to the 2x to the third power over 3 minus 1 over 2. So that is the particular solution. So we finished question number 1. Let's take a look at question number 2. Question number 2. So we found out that here there's no x value. So some people will be shocked. There's no x, right? What do we do? So we have to group the y plus 2 together to make it into a factor. Then I multiply the dx to this side. Now I can divide y plus 2 both sides. So now I'm going to rewrite it. So I'm going to get integral 1 over y plus 2 dy, and then just cancel out. You get 1 dx, or just dx. So u equal to y plus 2 du equal to 1 times dy. Is it 1, then you don't need to multiply, because times 1 and then multiply 1 over 1 is the same thing. So now I'm going to write it, okay, 1 over u, because this is going to be u to negative 1. So times du. And then here this time I'm going to integrate it. So I had 1, so it's 1x plus c. So the entire derivative 1 over u will be ln absolute value and now I'm going to get ln y plus 2 equal to 1x plus c. So to undo the ln, I had to use base e both sides. So now this cancel out, so I got absolute value y plus 2. So I got e to the 1x plus c. So that means e to the 1x times e to the c. So I'm going to let the k equal to e to the c. So I'm going to get k times e to the x. 1x is x. On the left side, stay the same. Now I'm going to get rid of the absolute value, so y plus 2 equal to plus minus k e to the x. So now minus 2 both sides, y equal to plus minus k e to the x minus 2. So now we're going to use the initial condition. So the initial condition is y of 0 equal to. So I'm going to pick the y equal to k e to the x minus 2 because 2 is positive. I'm going to use the positive branch. So now I get 2 equal to k e to the 0 minus 2. So I mean 2 equal to k minus 2 and k equal 4. So the particular solution is y equal to, you go back to this over here, k is 4, e to the x minus 2. So I finished question number 2. So let's go to question number 3. Question number 3. It looked a little bit different than the previous 2 questions. The 2 variables are w and t. So even though the variable change, but the concept stay the same. So now we got dw over dt equal to 1 over 25, and we got w minus 300. So step number 1, we're still trying to separate the variable. So now I'm going to multiply the dt to this side. Because I still had to divide the w minus 300. So now I'm going to divide the w minus 300. Now I get dw over w minus 300 equal to 1 over 25 times dt. So even though we have a different variable, but the concept is the same. So next step, we put the integral symbol. So I'm going to rewrite 1 over w minus 300 times dw. So let's take a look at this on the left side. It just looked like the previous question we did before. So this is the denominator. We know if you rewrite it, you're going to get the w minus 300 to the negative 1. So it means u equal to w minus 300. du equal to 1 times dw. So this is times 1 and times 1 over 1 is the same thing. So now you're going to rewrite into 1 over u and du. And I'm going to integrate this side, so I'm going to get ln absolute value, and I get ln absolute value w minus 300. Okay, so I finished integrating the left side. Now I'm going back to the right side. 1 over 25 is a number, so it'll be 1 over 25 times the variable. It was no longer x, so you put t. m plus c. So look at here, the duty of 1 over 25 times t is 1 over 25. So now we are going to undo the ln. So we put the e as the base. So now the ln cancel out. So I get absolute value w minus 300. And I get e to the 1 over 25 t plus c. So now I'm going to focus on the right side. I'm going to rewrite into e to the 1 over 25 t times e to the c. Okay, addition, you go back to the same baby with multiplication. So I'm going to let k equal to e to the c. So I'm going to get k times e to the 1 over 25t. The left side stay the same. So now we get ready to get rid of the absolute value. So that w minus 300 equal to plus minus k e to the 1 over 25t. And then plus 300. So w equal to plus minus k e to the 1 over 25t plus 300. So the initial condition, it was w0 equal to 1,400. So now I'm going to pick w equal to k e to the 1 over 25t plus 300 because positive. 1,400 k times e to the 1 over 25 times 0 plus 300. So this become 1. So k plus 300 equal 1,400 minus 300. So k equal to 1100. So the particular solution is w equal 1,100 because k is the 1,100, e to the 1 over 25 times t, and plus 300. So we finished the question. Now let's go to question number 4. Okay, number 4. So we have 5 minutes before we get cut off. So we got dB over dt equal to 1/5. So same idea, there are two variables b and t. So I'm going to multiply dt to the right side. So I got dB equal to 1/5. And this is 100 minus b. And then times dt. And I want to have the t on the right side. So I have to get rid of the 100 minus b. So divide by 100 minus b. Both sides. So now we're going to continue. Integral 1 over 100 minus b times dB equal to, so this cancel out, you get 1/5 dt, and I put the integral. Now I am going to take a look at this. So I'm going to make u equal to 100 minus b because that is the denominator, and you'll write it going to be 100 minus b to the negative 1. So we're going to use ln again. So du equal to 0 minus 1 dB, because that 100 you get due to 0, you have minus sign. So here we get a du equal to negative 1 dB. I need a negative. So we multiply by negative 1 and then multiply by negative 1. Negative 1 times negative 1 is going to cancel each other. So now we're going to have negative 1 integral, and then here become 1 over u, and then dB times negative 1 become du. And then I'm going to keep the right side stay the same, we're going to integrate a little bit later. So now we're going to have -1 stay the same, ln absolute value equal, so this 1/5 times t, because the variable is t plus c. So I want to get rid of the -1 before I substitute. So I'm going to times -1 both sides. So I'm going to get ln absolute value equal to -150 minus c. Now I'm going to have ln, I'm going to replace the u by 100 minus b. In order to get rid of the ln, I need to use the base e, so base e. So this cancel, I get absolute value 100 minus b equal to e to the -1/5 t minus c. Okay, so now I'm going to get e to the -150 times e to the -c, and then let k equal to e to -c. So I'm going to have k times e to the -150 on the left side, stay the same. Now I'm going to get rid of that, so I get plus minus k e to the -150 minus 100. So I get b equal to plus minus k e to the -150 minus 100. So now you can divide by -1, okay? So you divide by -1 both sides. So you get b plus minus divide by negative minus plus, basically plus minus. Okay, so we get k e to the -150. When you divide by a negative, you get positive 100. Okay, so basically this is plus minus k e to the -150 plus 100. So now we got b is 0 equal to 20. So we get 20 equal to k e to the -1/5 is 0 plus 100. So 20 is going to be e to 0 times k is k. So k equal to -80. So the particular solution is b equal to -80 e to the -150 plus 100. So we finished question number 4 just in time.